Okay, headed over to Canvas. We are in section 3.6, applications, the last section in our R module. Here we're going to learn how to create interactive dashboards, which are called applications, using the package Shiny. And the first thing we're going to do is load up the slides. So we'll be following along with the slides, and I also have a blank R document ready for me to go. So introduction to Shiny. So what exactly is this new package that we're going to learn? Well, a lot of this content comes from the Mastering Shiny textbook, so feel free to refer here for more information. We'll be covering an assortment of topics from this. So what is Shiny and Shiny UI Editor? So Shiny is an open source R package that provides an elegant and powerful way to build web applications. So essentially like Tableau, where we're kind of pointing and clicking and dragging and making our applications. We're going to do this with code now from the package Shiny. And it does all of that backend for us. So we don't have to worry about the HTML too much or the CSS or the JavaScript knowledge. We can just use our R knowledge to get a working application. And then at the end of the part 2 video, we'll learn the Shiny UI editor, which kind of takes one step away from us. So we can use it more like Tableau, where we're going to have R generate code for us. So that is going to be how we'll end this part 2 video. So demonstration of what an application is. So it doesn't work in the slides, but it works on my local version here. So our goal is to be able to create an interactive tool that allows our audience to have a deep look. So we want to kind of transfer the control to the user and let them explore the data themselves. So right now, what we're going to be rebuilding is an application about the iris data, where the user has the option to select which variables to look at. And they can optionally color by species. So giving this options to the user lets them kind of create their own narrative and explore the data more in depth than just a single or a few static images. So this is what we're going to try to recreate with Shiny. So big picture. Shiny can be very frustrating. It is kind of a new skill set, so we haven't really learned this type of coding before because we're going to be working with the user interface, which has some HTML elements in it. But we can actually make it better with a smart approach. So we're going to be kind of skipping to the end process, but everything that we've done before about cleaning the data, importing the data, figuring out which story to tell, how to create those plots with ggplot, with Plotly, all of those are going to be done before we move to the interactive app stage of a data analysis project. So for this lesson, we're just assuming we've already done all of that. We're just working with an easy data set iris, and we're going to just skip to the app version of our analysis. So what we need to do is think about how we can take the control out of our hands and give it to the user without kind of giving them explicit instructions. So we want to make it very user-friendly so that they know what features can be changed and how to do that. So we want to make a very intuitive interface. And a good way to do that is to sketch on paper what that interface is going to look like. So this is what you're going to have practice on doing in the project. And also thinking about the code structure. How can we actually get that interface to be coded? How can we get the server, which is what we'll learn, to map to what we want? So here's an example of the iris sketch that we just learned. So that application. So I have an X variable here with a drop down of the different variables. I have a Y variable with a drop down and a color checkbox for the color. And then we see the plot output in the main panel here. So kind of the layout that I have set up here is I have a sidebar with a few different input controls, and then a main panel with a single plot. So this is a very simple version of a sketch of the application that we just showed. Another one is going to be a simulation app. So here's just another example for sketches that you'll be creating. So this is a little bit more detail. So we have some words describing what the application actually does, some more input controls where we're just inputting a number, and we actually have an action button. And then we have a few different tabs. Each of these has different plots and a different results section. So we can get more fancy as we'll learn with the user interface, but we still want to think about the layout ahead of time before we jump in and actually start coding. So you'll get practice with this with one of the subtasks in the project. So how does Shiny actually work? So it uses a concept called reactive programming, which just means that the outputs change whenever the inputs change. So whenever the user changes something in the user interface, then that sends a signal to the back end to update the plots, and then it re-renders those plots. So it's a big circle. So the very first part of the circle is the user interface. So this is how your app looks. So there's going to be two pieces to every single Shiny app that we're going to make. There's going to be the user interface and then the server. The user interface is just the visual appearance of how the app looks for the user. It's actually running JavaScript behind the scenes, but again, we don't need to know that because Shiny takes care of that for us. And what happens is when the user changes something, when something is clicked, it sends data, it sends those inputs off to the server. And the server actually defines how your app works. So it is running R in the background. So this is where we use all of our R knowledge that we've learned in the past few weeks and creating our plots, creating those data transformations. And then once the server receives those inputs, it modifies the code necessary and then resends those finished images, those finished plots, finished data up to the user interface where it re-renders that. So it essentially is a big reactive loop, a big listening loop. So whenever something changes, a message is sent, data is sent, R reruns everything, and then sends it back up to display. That's kind of the big picture of how Shiny works. So we need to think about how we can design our applications to take advantage of this and be effective in how to get code to do exactly what we want. So we're going to start really simple. So our very first Shiny app, so the way that these slides are going to work is we can just copy and paste the code that I have here into that empty R document. And that is going to create our very first Shiny app. And then we'll dig into what each of these different lines does. So copy and paste that code. And when I save this, my run button is going to turn into a run app button. So before this, didn't mention it, but make sure to install the Shiny package. So install Shiny, make sure to run that. And when you save the document, it turns into a run application now. So if I were to run this, here is our output. Really, really simple. All it does is create a text string called hello world. But let's actually dive into what each of these pieces is. So first thing it does is calls library Shiny. This tells R that we're actually creating applications. So that gives us that run application. Then there's two pieces. So we define the user interface. So the way we do this is with UI, that's just what we name it. And we're going to give it the function fluid page. So we'll talk more about what that does, but we're just defining the user interface. And all it is doing is displaying this text. And then what we do is create a server, and the server is going to be a function. It's just a function of inputs and outputs. And right now it doesn't do anything, so it's empty. And then finally, we tell Shiny app to actually put these pieces together. So combine the user interface, combine the server, and create our application, which is what we have here. So that's very simple, but this is all the pieces. So we're just going to be extending what's in the user interface and extending what's in the server to create more complicated applications. So the first thing that we can do is rebuild the user interface for that Shiny application of the Iris Explorer. So what we need to do is we'll be adding the tidyverse because we'll be working with some ggplot eventually, but we need to look at the user interface here. So the server is going to stay the same, the run app is going to stay the same, and we are just going to update our user interface, and we'll see what happens. So now I reload application, and this is what I get now. So now what we did was we added user interface controls. So I added the dropdowns. So it's pulling these variable names from the list of variables for Iris. Notice it isn't actually doing anything. Checkbox doesn't change anything. We're just adding the controls. So let's dive into more what each of these lines does. So the fluid page is one way to show the user interface. So there's multiple different functions to kind of organize the structure of your Shiny application. Fluid page is the easiest way to do it, so that's what we're going to start with. And this is a layout function, so it sets up that basic visual structure. And sidebar panel, this gives us that panel on the left side. So it gives us the sidebar, and then we're filling it with some input controls. So the way the input controls work is it's going to be a select, meaning a drop down, and then capital input. And then what we do is we give it the possible values. So the possible values it can choose from is it's getting the names from vars up here. So all this does, if I run this line, is it just gives me a list of the variable names. So set diff just gives the variable names, and then I take out species because that is a categorical variable. So if I go to select input, we give the first argument is the input ID. So all of these HTML elements need to have an ID so that we can connect them from the server in the user interface. So the input ID is yvar. So it's going to be our y variable. The label is going to be what displays. So y variable here. And then xvar is going to be the input ID for the next one. And then choose x variable. That's going to be the input ID or the label for the next one. I need to update this photo, but this would be choose y variable. This would be the first one. And then choose x variable would be the second one based on this code. And then the choices, right? What is actually in that dropdown? That is what we specified with our vars. And then selected, if we look at selected, this gives us the initial value. So it defaults to the very first option, so sepal.length, and then we change it for the second one to sepal.width by setting it to the second item of vars. So I just want to set these as two different ones because eventually our plot's going to make a scatter plot, and we don't want to be plotting the same variable twice. So default first value, default second value. And then finally, to change the type of input control, it's going to be checkbox now instead of select. So it's checkbox input, same idea. We have the input ID, we have the label, and then the default value is going to be true. So all these different input controls just give us this different user interface, these different options. And then lastly, what we do is we create a placeholder for the plot that we're going to make. So we do that with main panel. So main panel, it doesn't actually do anything yet. It's just creating a spot for the plot. And then we're going to fill it with a plot. So we use plot output. So whatever type of output I have, in this case, it's a plot instead of a table. And then I'll give it an output ID. So we're going to be connecting it to the plot one when we get down to our server in the next page. So as far as what input controls are possible, if we take a look at this website here, this gives us all of our different options and the code to run them. So we can have an action button where we can get the code for that. So render print. In the UI, it's just action button. In the server, again, we'll talk about what the server does. But we can have single checkbox, we can have a checkbox group, we can input files, you can do date ranges, so you can do lots of different things like radio buttons, sliders. So these are things that you'll be exploring in the project. We're just going to give you a simple examples for the notes. Okay, so that is the basic structure of our user interface. So next up is going to be building out the server. So we're actually going to be adding content now. So adding plots, adding tables. So the strategy that we're going to use is to create static plots first, and then worry about connecting them to the user input. So first, we just want to make sure that we can get a working version of the plot in there, and then modify it to what we need. So what we're going to do is copy and paste our server code down here and replace our empty server and see what happens. So I'm just going to be replacing the empty server. And now I can run my application. And we see we get a static plot. So notice when I change these drop downs, nothing happens, right? It's currently just connected to a static plot. Because if I look at the variables here, right, it's always plotting sepal width, it's always plotting sepal length, and it's not even mentioning a checkbox of the color by species. So this is just getting that plot in there. So how does this code actually work? So what we have is we are giving Shiny a recipe. So if you recall in the user interface, we had a placeholder for plot 1. So in the output now, I am giving you a recipe for how to fill in the space of plot 1. So fill in plot 1, render this plot. So we wrap everything in a render plot, and we give it the ggplot code. That gives us the plot 1. So it just fills in the space with the particular plot that we want to make. So the way that we do this is we always specify output and the $, the input ID. So we're just we're creating an input list and an output list, and each element is going to be the recipe that we're filling in. So each render type, so in this case, render plot, gets paired with a type output. So render plot from here, I'm rendering a plot, gets paired with plot output. So because I'm making a plot, these two pieces need to match. If I was making a table, I'd have render table and table output. So I match this with this, and I match the ID with the ID, and this connects the two. So now in this placeholder, in the main panel, it fills it with the render plot code. And that's what we wanted to have happen. But again, how can we actually connect that to the user input? So that is going to be the next slide. So adding behavior now. So now connecting it to that user input. So when we change an X variable, like we saw, nothing happens. So right now it's always plotting these constant values. It's not connected to the user interface. The way that we change that is by modifying our server to include then instead of constant values, include the .data pronoun. So let's change our code. And then we will talk about what happens. So changing the code there. So render plot. So now I have a .data pronoun. This just refers to the general data. And in the input controls, right, remember that there is a bundled piece of data that gets sent down. So the bundled data from the user input gets sent as the input option, as the input argument, and xvar from here is given as a string. So whatever value is selected in this dropdown is given as a string in input $xvar. So it's going to be something like sepal.width. Right, so this value is going to be in input $xvar. Once the user changes this to maybe sepal.length, then this value updates and gets sent down to the server again. But remember, with our AES statements, I can't have strings here. So I need to have, right, this will throw an error if we try to run this ggplot code, right? That's when we first learned this in 3.2. So what we do is we use the data.pronoun, the .data pronoun, and we index it with the particular string that we want. So this is just getting us to that column. So this is just how kind of our workaround in ggplot is using this syntax to reference the column name because we have the column name as a string. And that goes into our AES statement. And then we can just make our ggplot like usual. So now when I run this code, rerun it. Had some copy paste errors. So now that I have this properly formatted, no duplicated code or anything for my copy paste, there is going to be, so just copying all of this code into here. Now when I rerun this app, we see when I change my variables now, the variables actually update in the plot as well. But notice that the color by species, we still haven't taken that into account. So that's what we're going to talk about next. But we've incorporated now the user input by connecting our user controls to our ggplot plot. All right, so next up is adding that last feature. So we want to add in the color by species. So the way we have to do this is actually by building our plot in stages. So if I take a look at the code here, we're going to first build a base plot. So I'm just going to give it the theme after giving it the standard ggplot function. So P1 is going to just be a blank canvas, and then I'm going to conditionally color based on the value of that checkbox. So if my checkbox input $species is equal to true, I want to use that same code to create the ggplot, except I want to color by species. So if species is true, update P1 and make it color by species. Else, update P1 from the base plot and just have it as the previous plot without colored by species. And then at the end of that, we have an updated P1 based on this checkbox. So then we just print it. So let's go ahead and update our server function to this code. And then when I rerun this application, now with my checkbox, I am setting this value as true. So it's using this code to update P1. So it's colored by species as desired. Then when I uncheck it, now it takes away that color because it's using, now it's set to false. Now it's using this code. So change this value from true to false when I uncheck that box, and then I'm still printing that final P1, which is conditionally updated. So that's the logic of how to get this to color by species. So we have officially replicated our working version of the Iris application. So next up, we're going to be a way to help you in your design process by understanding a bit more how Shiny is working, how it's sending that input and output down. So like I said, we always want to start with a sketch of the app. So before you start coding up the user interface or using the Shiny UI editor that we'll talk about in part 2, we always want to sketch a blueprint of the app so that we have a goal in mind. And then we want to use those static images to create the visuals that we want. And then what we can do is actually kind of replicate Shiny and create an input list and simulate how the interactivity would work. So the way we're going to do that is I'm going to open up a new R file. And I'm going to copy in the server code. So this is kind of all pre-work before you get to the actual application. So again, we don't want to skip right to the application, right? That's going to spend a lot of time fiddling with the application, and it might not even be the plots that we want. So if I have my code here, so again, all this is doing is creating that plot. If I try to run this code, notice that it doesn't have the input. So we're going to act like the user, and we're going to create the input list. So all that user interface does when it bundles that data is it's creating a list, an empty list called input, and then it's filling it with values. So the values that I have here from the user interface that I'm replicating are going to be X bar, and we'll just give it a variable name. So imagine the dropdown is selected as pedal.width, and then input $y bar. This is going to be, we'll say sepal.length. And then the last one that we have here is input $species. And we'll set it to true. So the flow here is I created the sketch. I know what I want the user interface to look like. Before I even go to that, I have created my server, what goes inside of the server, right? The static images. And now I'm kind of simulating how the user is going to interact with this. So I have 3 values that are going to change. They're going to be X bar, Y bar, and species. And so when I have the code set up to take into account this user interface, this is when I can run all of these. And now when I run this code all together, it creates my plot. So now simulating the user, let's say I change this to pedal.length, and I want to not color by species. If I rerun this and then rerun all of this code, now I'm acting like that user, and this is what should update. So from this stage, now that I know how the user is interacting with this, I know it's working, I can then put this into my application. So just kind of building your application in steps. First step would be creating those static plots, and then creating that user interface, right? Sketching it out, thinking about what's going to change, incorporating those changes into your static plots, simulating the user, and then once we know we have it all working, then we can transfer this and put it actually in the server function once we have our user interface made. So that's a very good strategy of how to save yourself some headache while creating these Shiny applications. So again, all that input list is just a list with a bunch of different values. So that's what we just demonstrated. And that gets sent back and forth between the server and the user interface. So whenever we are working with designing apps, we want to make it as seamless as possible for the user to have a good experience using our app. So there's a few things that we can do to kind of make it more user-friendly. The first thing that we'll go through is how to rename variables so that we see kind of contextually more easy readable names as opposed to R's variable names, but we still need R to have access to those variable names. And then finally, we can update our dropdowns so that in our application, if I go back and run the app, right, we don't want the user to be able to plot sepal.length and sepal.length, right? This is kind of a meaningless plot. So how can I update my X variable so that it takes out sepal.length so the user can only create valid plots, right? Those are 2 good design principles that we are going to incorporate. So this is when we get to the polishing the plot stage. So to fix the names is actually going to be really simple. So all we have to do is translate those variable values to the labels. So the way we're going to do that is with a named vector. So what I have to do is outside of the user interface and the server, I just have to create this named vector. So the name is going to be a string of the nice human readable name, and the value is going to be the variable name. So sepal length, centimeters, spaced out, looks nice, is equal to, maps to, variable name sepal.length. So I create this in my application. I am going to redefine bars. So we're going to use this version of vars. So then it will automatically update down here. So that takes into account the user interface. Then for the server, what we have to do is, again, we're going to be conditionally coloring by species, but we're going to be building our plot in stages again. So now this stage, we have rearranged things a bit. I've moved the ggplot into the P1 for the true, and I moved ggplot into P1 for the false. And then the last building stage is going to be adding those labels. So my X label, I wanted to change based on the dropdown, and I need to get it from the names. So what we do is we index this vars based on which one is selected. So vars equals input $var. This gets me to the one that is selected, and then I'm pulling the name. So name of vars returns a long vector of the column names, and then I'm just doing names var sub 2, for example. And this should ideally pull the second one, but if I were to do sepal.length, so I had a typo there, so it is going to be names vars, and then I pull the second option, and that's pulling the actual name. So that's all this is doing, is it is subsetting the names vector to the specific one that is given. So let's go ahead and update our server function, and we can see the result. So now when I run this application, we see in our dropdowns, right? This is when we change the user interface. In the dropdowns, we have nice names now. And in our plot, we also have a nice x-axis label and a nice y-axis label. And again, those still have all those other features. So named vectors is how we incorporate the translation of readable names to variable names. The last thing that we can do is actually a really simple change, is going to be a conditional dropdown. So our goal is to update the input for the independent X based on what is chosen for the response Y. So based on our response variable, what is chosen for Y, I want my list to change to update and show only the other three options so that the user cannot create that diagonal line plot. So the way we do this is actually really easy. All we have to do is use the same code. We're just going to add one thing to the server. So because of this updating based on the data, the server has to do all of the thinking. So in the server side, we're going to add the observe event. So listen for a change in the Y variable. When that happens, update the select input. And what we're going to do is we're going to change the choices. So change the choices of our X variable, and we're indexing it based on everything that's not Y. So the choices should be everything that's available except what is chosen for Y. So all we have to do is add this simple 3 lines of code to our application. Above the output plot 1, all of that stays the same. Now when I run my application, sepal.length is selected. Now sepal.length is not an option for me. If I change this to sepal.width, now sepal length is an option, and sepal.width is not an option. So that is how we can use the conditional dropdowns with the observe event. And again, we can do that with all types of inputs. So if you have an input slider or an input radio button, right, all of those can be updated using the same strategy. We just use the corresponding update function. So some other things that are possible, we can do conditional panels. So maybe you don't want to show some information unless the user selects something. That is when we can take into account a condition and optionally show something. So that we do that with the function conditional panel. It's fairly simple. There's some sections in the textbook about conditional panels. And then you can also create code, create that user interface code with using UI output and render UI. So let's say you have a general data set and you want to create an input control for every single column, but it changes based on how many columns you have. So in essence, you are creating code with code. So what you're doing is you are creating more input controls from a function that is giving you more different ways to select the different columns. So it's kind of creating an arbitrary number of controls. And to do this, we have to use some techniques that we haven't learned before from the per package, but just giving you an idea of what is possible. So there's a really good explanation of this in the textbook when it comes to dynamic UI. So there is lots of good explanations and pictures drawn out in here. So creating code, creating user interface with code is the section I'm referring to there. So very last thing that we'll talk about for this video is going to be how to incorporate Plotly within our Shiny. So this is actually going to be a really simple change. All we have to do is change the type of output that we have. So instead of plot output, we're going to have Plotly output. So instead of plot output, it's Plotly output. But what we're also going to do is add a new tab. So you can see here in the screenshot that I have my original ggplot code, and then I want to use tab set panel and tab panel to create another plot. So tab set panel gives you the placeholders, and then within each of those, within the first tab that's titled ggplot, I'm placing my plot 1, and then I'm going to create a placeholder in the second tab titled Plotly 2 for my Plotly output. So let's go ahead and update our user interface to this new code. And we're also loading the Plotly package because we'll be needing that for the render Plotly. So again, we're just extending the user interface by creating another placeholder. So when I run this, now I see I have 2 tabs, but there's nothing in the Plotly tab. So ggplot tab, this works as directed because there is something going into plot 1. There is a recipe for that, but there is not a recipe for Plotly in this placeholder yet. So that is what we can add with the server. So to do the server, all we have to do is now a similar process. We're going to just add an output plot 2. And instead of render plot, we have a render Plotly now. So all this is going to do is create a static plot. Again, we're going to use that same strategy. We're going to create a static plot and then worry about how to get the input controls in there. So first, let's go ahead and add the recipe for plot 2. So I'm just copying the plot 2 related information, and we're going to add that to our server below plot 1. So now I have my second plot. So I forgot to copy over the close bracket and the parentheses, but once I copy that over correctly, I can reload my application. And now if I go to the Plotly tab, I now have a Plotly image. So adding that interactivity on top of the interactive user interface features. But notice, again, my Plotly one isn't connected to the data, isn't connected to this user input. So that's the next step. Continuing on with the same strategy, right? We have the same flow. We're building our Plotly in stages. So the first thing that we did is we added the iris data to our Plotly statement, And then we conditionally added markers. So again, using the same strategy as conditionally coloring by that third variable species. And again, I used a static variables now. So just the constant petal.width, petal.length, and then color by constant color black, identity function black for not coloring. So when input species is false, and then I'm going to hide the legend because I don't need the legend when they're all a constant color. And then again, we print our plot. So same exact flow in plot 1 and plot 2. Now I'm just using our Plotly knowledge to give us our interactive dynamic plot there. So now what we want to do is update this so that it takes into account the user input. So just like with the ggplot, when we had to use the .data pronoun, the input var is coming in as a input x var is coming in as a string. So in Plotly, what we have is going to be a formula. So the tilde is again is R's way of creating a formula. So we actually need to convert this string of input $x var into a formula. The way we do that is by adding in this code here. So we paste together the string version, so the tilde followed by the variable, and then we convert that to a formula. So that's all this line is doing. This is the same exact process as doing the .data, just Plotly's version of it, because we need to have a formula rather than the variable names in, or a variable column in the AES statement. So let's go ahead and update our output plot 2 to include our new user input information. Now when I run this, and I go to my Plotly tab, and I change the variables, now it's updating accordingly. So that is going to be how we can update the Plotly stuff with the user information. We could do a similar process. Notice that the variable names now are not the nice ones. So we could do a similar process with the layout function to change the x-axis and the y-axis titles, but we'll leave that for further exploration for you. So very last thing is going to be the additional Shiny features that we'll just briefly mention. So we've only really worked with the simple layout structures with Fluid Page, but there's lots of different ways that you can lay out an application, right? Think about Tableau, all the different ways you could organize a dashboard. So this diagram is really helpful in showing the different functions to use in the different results. So I could use sidebar panel layout, sidebar panel, main panel. This is the one that we have been doing with our title panel. But I could also have kind of 2 rows, fluid row, and you're specifying the columns. Maybe I have 4 different plots in here, or a table and a few different plots, or a text box and a few different plots, right? There's lots of different ways that you can organize a page. And here is a set of the few functions that you can use to help with that, all these different layout functions. Then you could also have a navigation bar. So rather than having tabs, you could have a nav bar. So that's all the user interface things is that we can change. On the server side, we haven't really talked about one really big piece, and that is called reactive programming. So right now, every time, if I have this application down here, we are generating distributions, density plots based on the values of lambda. So these are some Poisson distributions. We could add in a feature like an action button so that every time I change an input, it doesn't automatically re-update, doesn't automatically take a new sample. It can wait until I select the action button. So we're controlling when Shiny does the output, right? That's the advantage of reactive programming. So this will be kind of further knowledge for you, maybe something that you can incorporate into your project is going to be how to kind of delay when Shiny updates based on a different action, so such as an action button. So those are things that are possible with Shiny as well. And again, there's a lot more about that in the textbook. but just covering the basics now should be good to go for learning what to do on the project. So in the next video, we'll talk about some big picture stuff and then learn how to use the Shiny UI editor. So I'll see you in the next video.